Welcome back. Problem 12-42. So this problem is taken from chapter number 12, that is Deflection of Beam and Shaft, and the book name is Mechanics of Material by RC Hibbeler. So statement is the beam is subjected to the load shown. Determine the equation of elastic curve. EI is constant. So you can see this is the overhanging beam having a roller support at point A and pin support at point B, and from over a distance of 1.5 meter there is a uniformly distributed load that is 6 kilonewton per meter at this end we have a point load of 20 kilonewton per meter. So you have to determine the equation of elastic curve. So we'll solve this question by using Macaulay's method. So first what we will do is that if you remove this support at point A, so you will be having a reaction force, let this is RA, and if you remove this pin support at point B, so you will be having a reaction force which is RB. So we'll find this reaction force by using equation of equilibrium. So first equation of equilibrium is that sum of all moments about point A is equal to 0 and taking the counterclockwise movement as positive. So about point A, the first movement will be produced due to this distributed load, and this distributed load when converted into point load, so it will be 6 into 1.5, and the perpendicular distance will be 1.5 divided by 2, which is 0.75. So I will write, if this uniformly distributed load is converted into point load, so 6 into the distance over which it acts, 1.5, which is equal to 9 kilonewton, and it will act at a distance of half of 1.5, which is 0.75 meter. Okay, and this is producing counterclockwise movement, so it will be positive. So I will write 9 into 0.75. The second movement that is produced at point A is this one, which is RB into perpendicular distance is 3, and this is producing counterclockwise movement, so it will be also positive. So plus RB into 3. The last moment that is produced by this 20 kilonewton and perpendicular distance is 4.5, and this is producing clockwise, so it will be negative. So I will write minus 20 into 4.5, and the sum of all this movement about point A must be equal to 0. So from here you will get 6.75 plus 3 times RB minus 90 is equal to 0. So what we will get is 3RB will be equal to 83.25, and if you divide 3 on both sides, so you will get 83 divided by 83 divide 0.25 divided by 3 will give you 27.75 kilonewton. So this is the value of RB. Now we'll find RA by using equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see one force which is minus 9 that is acting downward, plus RA plus RB minus 20 will be equal to 0. So I will write from here, you can see minus 9 plus RA plus RB, which is 27.75 minus 20 will be equal to 0, and when you calculate it you will get RA will be equal to 1.25 kilonewton. Now you have RA and RB, so we'll find equation of elastic curve, and you know that equation of elastic curve can be obtained by using this formula, which is EI into D square V over dx square is equal to moment. Since we are applying Macaulay's method, so what we will do is that you can see different scenarios. This is moment, this is for point load, this is for distributed load, and this is for triangular loads, and the moments equations are mentioned over here. Now you can see here you have a uniformly distributed load that start from here, so our x start from here, and you can see this is over a length of 1.5, but in this case of distributed load, the distributed load starts from any point and it should be till the end. So what we will do is that we will add this till the end, clear, and with this we will also subtract the same at the bottom. So it will cancel the effect. So what we will do is that I will draw the free body diagram again. So we will take this uniformly distributed load till the last, and its magnitude is 6 kilonewton per meter, 6 kilonewton per meter. And this was point A where we have RA. So RA is 1.25 kilonewton, and here you have RB, which is 27.75 kilonewton. And in order to cancel the effect, what we will do is that we will add the same distributed load over this length in upward direction. So this length is 3 meter. This is 1.5 meter, and this is again 1.5 meter, and this will be also 6 kilonewton per meter. So what we have done is that we have added a distributed load over a length of 4.5 in downward direction, and we have also added 6 kilonewton per meter over a length of 4.5 meter in upward direction in order to cancel the effect. Now we'll apply this table to get our required moment equation. So I will write moment equation. So for first, this uniformly distributed load of 6 kilonewton. So you can see X start from here, clear? And here in this case, for this load of 6 kilonewton, A is equal to 0. So moment equation is this one, which is W naught by 2. So W naught is 6. So 6 divided by 2 into X minus A. So A is equal to 0 because this load start from this end. So X minus 0 power 2. The second load will be point load, which is 1.25. So for point load, you can see this is upward force. So moment will be this one. So plus RA, which is 1.25 into X minus A. A is 1.5 minus 1.5. Now one more thing is that this uniformly distributed load is downward direction, and for plus moment it is upward. So this will be minus. Okay. The third one will be this uniformly distributed load, which is acting upward. Now this is acting at a distance of A from this end. So I will write the moment function will be plus W naught over 2. W naught is 6. So 6 over 2 into X minus A. A is 1.5 times square. Clear? And the last thing is 27.75 kilonewton. So plus 27.75. Why plus? Because you can see force is upward, so moment function will be positive, into X minus. Now A will be equal to this distance. This is A for this load. This is A, and this A is 4.5. So I will write X minus 4.5 power 1. Okay. So if you further simplify this moment equation, it will be equal to minus 3x square plus 1.25 times x minus 1.5 plus 3 into x minus 1.5 square plus 27.75 into x minus 4.5. Now put the value of m in this equation. So you will get e into I d square v over dx square will be equal to minus 3x square plus 1.25 times x minus 1.5 plus 3 into x minus 1.5 square plus 27.75 into x minus 4.5. So what we will do is that integrate this equation, integrate it, you will get EI into dV over dx, where V is deflection, will be equal to minus 3x cube over 2 plus 1.25 times x minus 1.5 square divided by 2 plus 3 into x minus 1.5 power 3 divided by 3 plus 27.75 into x minus 4.5 power 2 divided by 2, and there will be a constant of integration C1. Let this is your equation number 1. Again integrate equation 1, so you will get EI into V, which is deflection, will be equal to minus 3x4 over 8 plus 1.25 into x minus 1.5 whole cube divided by 6 plus x minus 1.5 whole power 4 divided by 4, 3 will cancel, so 4 plus 27.75 into x minus 4.5 whole cube over 6 plus C1x plus C2, and this is your equation number 2. So if you further simplify it, you will get EI into V is equal to minus 0.25 x power 4 plus 0.208 into x minus 1.5 times cube plus 0.25 into x minus 1.5 whole power 4 plus 4.625 into x minus 4.5 times cube plus C1 into x plus C2, which is we will write this as equation 2 because this is the simplest. Okay, now C1 and C2 are unknown constant of integration, and we can find them by using boundary condition. So boundary conditions will be used to find C1 and C2. So what are the boundary conditions? So first boundary condition is at x is equal to 1.5, we have deflection is equal to 0. Let me show you. Here you can see x is equal to 1.5, we have deflection is equal to 0 because there is a roller support. So what we will do is that put in equation 2. So what we will get, EI into 0 is equal to minus 0.25 into 1.5 power 4 plus 0.208 into 1.5 minus 1.5 power 3 plus 0.25 into 1.5 minus 1.5 power 4 plus 4.625 into 1.5 minus 4.5 power 3 plus 1.5 x, sorry, C1 into x. So x is 1.5, 1.5, C1 plus C2 will be equal to this one. So from here this is equal to 0, and this term will be minus 1.266, this term will be 0, this term will be 0, and this term will be also 0 because 1.5 minus 4.5 is minus 3, so anything that is negative inside the Macaulay bracket will be 0. So this will be plus 1.5 C1 plus C2. So from here you will get this equation is 1.5 C1 plus C2 is equal to 1.266. Let this is your equation number 3. Now the second boundary condition is that at x is equal to 4.5, we have deflection is equal to 0. So let me show you here x is equal to 4.5 and we have deflection is equal to 0 because there is a pin support. So what we will that put in equation number 2 again. So EI into V is 0, which is deflection, is equal to minus 0.25 into 4.5 power 4 plus 0.208 into 4.5 minus 1.5 power 3 plus 0.25 into 4.5 minus 1.5 power 4 plus 4.625 into 4.5 minus 4.5 whole power cube plus C1 into X. So X is 4.5, so C 4.5 into C1 plus C2. So 0 is equal to minus 102.516 will be this value plus 5.625 when you calculate it will be this value, and this value will be plus 20.25, and this will be 0 plus 4.5 C1 plus C2. So from here you will get 4.5 C1 plus C2 will be equal to 76.641. Let this is your equation number 4. Now equation 3 and 4 are simultaneous equation. So solve equation 3 and 4 simultaneously. It's very easy. You will get C1 will be equal to 21.52 and C2 will be equal to minus 36.42. So this is the value of C1 and C2. Now put C1 and C2, in equation number 2 to get the equation of elastic curve. So when you put it, you will get V will be equal to V is equal to 1 over EI into minus 0.25 x power 4 plus 0.208 into x minus 1.5 whole cube plus 0.25 into x minus 1.5 power 4 plus 4.625 into x minus 4.5 power cube plus C1x. So C1 is 21.52x minus C2. C2 is minus 36.42. Okay, so again, if kindly make a correction over here that this C1 is 25.12 and C2 is okay. So this is 25.12, and this is your required equation of elastic curve for the loading. So if you want to have deflection at any instant of x, so put the value of x over here, so you will get the, and if you know E and I, so you will get the deflection at that length of the beam due to the loading. And that was all about this problem 12-42. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also check the description box where I have mentioned all the links of all the chapter playlist where you will find different problems that is explained in a very easy and simple manner. If you have any question, you can ask me in comment section. Thank you for watching.